Okay, I got interrupted that time, so I guess this is going to be 3 videos. Maybe 4, who knows? All right, so you got that. I think when I did this before as 3 halves x over y, derivative easier. You might try that. Okay. This is just simple differentiation. This is rule. All right, so f of x here is u, where u is 3x squared plus. So df dx is derivative of e to the u with respect to u is e to the u times the derivative of u with respect to x is 6x. So that's equal to e to the 3x squared times 6x plus 1. F prime of x on the second one. This should be easy. Twice u times the derivative of u, which is 1. Let's put the x there. The derivative of 3 log x is 3 times the derivative of log x. And that's it. 7 to the 2x. I always forget this, so sometimes I do it a different way, but this is f df dx is, let's do it this way, equal 7 to the u, right? So df dx is going to be derivative of 7 to the u times log 7 times the derivative of u, which is 2. That's 7 to the 2x times log 7 times 2, the 7 and the 2 in the front if you want. Okay, bottom one, same deal, right? But the way I did it, f of x equals 15 log base 10 of x, right? And then now we take the derivative of that. F prime of x is equal to 15 times 1 over x times 1 over natural log of 10. All right. Some people lay x to the 15 in there, and that's fine. And so they got x to the 14th on top and x to the 15th on bottom, but those cancel nicely. No problem with it. Okay, next one. All right, we're using L'Hopital's rule, but don't forget to check, because the bottom one you just plug in. The bottom one doesn't satisfy L'Hopital's rule, so you have to just plug it in. Right? With the rest of them, with the top one, if you plug in 2 in the top and bottom, you will get 0 on top and you'll get 0 on bottom. So if you differentiate the top and the bottom, that's L'Hopital's rule. So you get 3x squared on top and 4x cubed plus 2 on. Now substitute that in, you get 12 over 34. A lot of people simplified 12 over 34. I wouldn't do that. Same thing with the second one. If you plug in 2, sine of 2 pi is 0. 4 minus 2 squared is 0. So again, this equals the limit as x goes to 2. Differentiate the top, you get minus 2x. Differentiate the bottom, you get cosine pi x. Keep in mind times pi. You got to use the chain rule in there because you got a pi in there. You have to differentiate pi x. Right? Now plug in 2. Cosine of 2 is 1. So this becomes minus 4 over pi. Okay? Bottom one, just plug this sucker in. 4 plus 1 over 4 minus 1. 5. A lot of people made an addition error there. I don't know why, but they did. Okay. Next one. that the last one? That's the last one. Okay, this is too hard, all right, guys? So if you did the first derivative, I gave you credit. If you got both the first and the second derivative, then you got credit. This was put on the last page to let you know that you can't do this except with logs. So you got to do log differentiation to solve this problem. So if we let y equal to the x squared, and then take the log of both sides, the right-hand side, the natural log of x to the x squared, that x squared comes out in front. Log y equals x squared log x. Okay, now we can differentiate. So we get 1 over y prime on the left, and on the right you use the product rule, all right? X squared times 1 over x plus 2x times log x. So y prime equals x to the x, I plugged in the y there, times x, because I canceled, plus 2x natural log of x. Now we have to differentiate again. Okay, I'm gonna sort of leave that as this is y, right? This piece is y. And that'll be in a minute. Watch. So I'm going to use the product rule and the addition rule, and y double prime is equal to the first y times the derivative of the second, which is 1. And now I used to have the product rule for this part. 2x 1 over x plus 2 times log x plus y prime, right, we're using the product rule still, times x plus 2x log x. Okay, now just plug everything back in. Y double prime equals, what's y? Y is that, x to the x squared times 1 plus, and we can do a little bit of simplifying, 2 plus 2 log x. I didn't make a mistake there, did I? No, I didn't. Plus y prime we know to be that thing up here, x to the x squared times x plus 2x log x times, where is it? Times that. X plus 2x log x. And yes, we can simplify this further, but I wouldn't do that. Okay? That it? I think that's it.